Tem que fazer um leve juiz. Pô. Essa média com bandeira vermelha que tem SMS. Eu duvido. É assim que eu sou, é assim que eu vou de estudo, né? Isso aqui é um doença, chama. Me perdoe,
use it. It's called a fifine. So a fifine program is translating one language to another. It could be any language. Today, often we'll talk about the concept of source code to machine code. So this is Apple or Google or Microsoft or most other companies that use the version. You and I are actually going to download the compiler and use it to actually get our computer to understand the source code that you and I write in these higher level languages. So where are we going to do that? We could actually give instructions. You could download the program free, open source software onto your Mac or PC. The reality is that so many technical support headaches. We all have slightly different computers. We all have slightly different versions of Windows or Mac OS or Linux or other operating systems, and it too easy to start at the beginning of any course like this or learning programming. So we're going to use the cloud instead. We're going to use a URL of the form https://cs50.dev. And what this will do for you is put inside of your browser window absolutely everything you need for the course, but it's going to use software called Visual Studio Code, otherwise known as VS Code, that's actually free for itself. It's very popular in the industry. It's what real programmers use every day, but it's a cloud-based version thereof. So everything will just work for you out of the box. But toward the end of CS50, the goal is going to be to get you off of CS50's infrastructure, to get you to download this free development software onto your own Mac or PC if you so choose, so that those training rates, so to speak, come off. And even if you never take another class again, you don't need any class infrastructure moving forward. Everything you want and need on your own Mac or PC. But for now, it'll save us some time. So in just a bit, I'm going to go to that URL myself on my computer, and I need to see an user interface that looks a little something like this. The colors might be different based on your setting, fonts might be different, and so forth, but in general, it consists of a few different regions. So over here at the top is where we are going to start writing code today. So it's a tab interface, like any number of programs nowadays, and this is that same C code we saw on the go. So this is where we're going to start typing. Over here at the bottom is what we're going to call a terminal window, or a console. The terminal window is where we're going to type commands for compiling our code, for running our code. And you'll see today a contrast between a graphical user interface, or GUI, with menus and icons that you can click and are very familiar with, versus a command line interface, or CLI. And so we're using both of these together. And command line interface means down here, you only use your keyboard. You can click if you want to, it's not going to do much, because command line interface takes commands at the keyboard. So in here, it's going to feel like taking a step backward for the Mac. You see the icons and we all have, which are very graphical, but it turns out when you become a computer person or a programmer, you can be a lot more productive, a lot more efficient, I dare say, by running hard command line interface and using both types of interfaces for what you should do. So more on that in just a bit. Over here at left, you're going to see a folder interface like Mac OS or Windows, where any of the files or folders you create in CS50 are going to end up as well. So it gives you sort of the best of both worlds. You can type on the left, or you can type command on the bottom, as we'll see. And then along here, there's a so-called activity bar, which is VS Code specific features, but also CS50 specific features. And if you're in your own version of CS50.dev, you click through, .menu, or zoom out, you see everything, you'll see CS50's own rubber duck virtual speaking that will be there throughout the course, answer any and all of your questions as well. So more on that soon too. So here's the code that I propose that we write first, just like we go to our very first Scratch program, to say hello world. So let's go ahead and do exactly this. I'm going to switch over to this screen here, where I've already logged into CS50.dev on my computer, and just to keep the focus on the code, I've hidden the activity bar, I've hidden the file explorer, so to speak. So you're seeing here the area where all my tabs are about to go, and the terminal window where all my commands are going to go. But this is why you want to keep focused on the interesting parts for now. So how do I go about actually writing and compiling and running some code? Well, the teaser is going to do these three steps. One of these is a command called actually code, and code is just going to let you open or create a new file, a file called hello.c. Make is going to be, for now, a compiler that allows you to make the program and convert your code into machine code. So from C to 0 to 1. And then weirdly, we'll see my /hello is going to be the command to run my actual code. So the textual equivalent of like double clicking a Mac or PC icon or tapping an icon on your phone. So that's it. These three commands are on to write, to compile, and to run code all over. So let's go ahead and do that. Back in my VS Code interface, I'm going to go ahead and run code hello.c. And there's a couple of details here. So one, there's a clear dollar sign, which has nothing to do with currency, but it's just a common convention in the programming world to represent your prompt. So if a TF buyer say go to your prompt, we really go to your terminal window with the dollar sign, and the dollar sign is where you type the command. Sometimes it's a different symbol, but the dollar sign is convention. Now that I type code space hello.c, I'm going to go ahead and enter. And maybe not surprisingly, this gives me a brand new tab, a new file if you will, called hello.c. And just like Word documents have their own file extensions like .x, and Excel files have .lsx, and .pf and .pdf, and GIF have .pdf, and so forth, so EC files have a file extension by convention that is .c. Now a couple of minor points. Notice that by convention, I'm almost always going to name my files in lowercase. By convention, I'm never going to use spaces in my file name, and my file extension 2 is going to be lowercase. Long story short, accidentally hitting the space bar or using file names with spaces just tends to make life harder when you're in a command line environment. So just beware, silly, stupid things like that. So all lowercase, no spaces for now. So my cursor is literally moving because the program wants me to write some code. I'm going to do this from memory. It'll take you presumably some time to acquire the same instinct, but I'm going to go ahead and type this first line here. Now, include standard io.h. More on that soon. Int main void. It's parentheses thrown in. Notice what's about to happen here is a little interesting. In the code I want to type, I want what we'll call curly braces, sort of squiggles. You don't use often in English, at least, but are there on your keyboard somewhere. But notice what VS Code does in a lot of programming environments is it finishes part of my call. So I'm only going to type a left curly brace, but notice I actually get two of them. And if I hit enter, notice that not only does it scooch one down a bit, it also indents my cursor, because just like pseudocode last week, whenever you're doing something logically that should only happen if the thing above it happens, similarly this indentation is going to be a thing when you actually write code. So VS Code programs like it, just try to save us keystrokes so I don't have to waste time hitting the space bar, hitting tab, or sort of wasting my time like that. Alright, so with that said, I'm going to type the last of these lines, print f, where the f is going to be formatted, and then a parenthesis, and notice it gives you two, give you the second one for free. Sometimes it'll give you can certainly override this, delete it, and start over. And now unlike Scratch, you can see, it turns out I've been using double quotes anytime I'm using a word or a phrase, anything like that matter. Hello, comma, world, and then at the very end of my line, much like when you use a period, I'm going to use a semicolon. So that's a lot of talking, but it's not coding. It's actually 6 lines of code, but honestly, the interesting one intellectually at this is really like that is the equivalent of that say block. Now here we are across my fingers, hoping that I can take any typographic errors, it can automatically save for me, and I'm going to go back to my terminal window, where now I'm going to use that second command, make space hello. Common mistake, you do not say make hello.c, because you already made that file. You say make hello with the name of the program, and in this case I do want to remove. And make it smart, it's going to look in my folder, and if it sees a file called hello.c, it's going to convert that source code to machine code, and take the result, and simpler, shorter file called hello. I can't remember that. Now hopefully nothing will happen, and that is a good thing, quite paradoxically. If you do anything wrong when programming algorithms, you want or many more lines of errors or yelling at you that you made a mistake, seeing nothing happen is actually a good sign. So the last command to run my code with all our three steps here, we create code to create the file, make, compile the file from source code to machine code, so lastly is ./hello. So this now is the equivalent of like double clicking on Mac or PC or single tapping on a phone. Enter. So close. Alright, pretty good.
quase todo mundo sobre
take some introduction to the syntax. You fix like the simplest instinct like you do this, or we just get like this. But it's not always rubbing the wrong way. Because in general, we're going to see that programming in C and in Python and other languages tends to be line based. Like you really start and finish your thought on one line. So if you're going to have an enter like this, it's for finishing your thought on the next line. Generally, programming languages don't like that. Make hello, we're making that change, enter, and there we have like the first of our erroneous output. And it's yelling at me, it's character, it's red, it's green, long, sometimes you can have error messages record, sometimes you can have a software brain figure it out. But for now, I've spoiled it. Obviously, enter is not the right solution. So let me clear my terminal window, apply that error, let me delete this, and so backslash n turns out is going to be this sort of magical way of ensuring that you actually get a new line at the end of your output. So when you go now and rerun make hello, because I changed my code, now reconvert, recompile, source code to new code, /hello, and now there, common hello world program. So for now, don't worry about the include, don't worry about saying, don't worry about kids, more making more with other characteristics, but primarily on line 5 here, and of course today is equal to teach part, the other characters, and now you can take this one page down. Questions though, on any of these? Sure, why is the backslash n inside the quotation marks, if you will? So your answer is that that's just a little bit very easy, because inside the quote is the input that you want printf to output to the screen. So if you want printf, this function, to output a new line, it must be included in the quoted text image. Exactly, backslash n is a special pattern that printf knows I should move the cursor to the next line. A good question. So what if you actually want to print backslash n? Things get a little tricky there. Let me go ahead and propose that we do this. So it turns out, with authentication programming, when you want a literal character from here, you actually put another backslash in front of it, but it's not going to be something to do with there is a backslash solution for that. So let me propose that beyond that now, these are some characters that you actually do. Here is the first backslash programming wrote with the green flag there. Here recall, the link model that proposes everything you do, whereby functions are just implementations in code and algorithms, step-by-step instructions for solving problems. The input function is called mathematical arguments or context parameters. And sometimes functions have last line with scratch, there was a speech bubble that magically appeared next to half mouth, sort of side effect. So just like this, then we had the white oval as input.
Bro!
The same block was a function last week, and then we had this here side effect. Well, how do you compare these things left to right? Well, here's the same block left. Let's figure out go to right. Notice a couple of things that sort of adapt from scratch.
Echo,
almost the name
Luiz Vermelho.
We'll eventually see. Notice parentheses in C are kind of evocative of the oval in scratch, and that's probably why MIT chose an oval, because a lot of languages use parentheses in this way. You can still write hello world just as we did last week in scratch, but per our demo thus far, you do need the double quotes, and double quotes, not single quotes, double quotes on the left and right, and in order to get that new line,
Echo,
backslash n, and one more
Luz vermelha.
the semicolon to finish your thought. So all these sort of stupid things now that honestly you will forget initially if you've never programmed before, but you'll soon, in days, in weeks, develop the muscle memory, where all of that stuff just jumps off the page right at you. Alright, so these escapes, this backslash n is generally known, just so you know, as an escape sequence. And so backslash n allows us to specify a character that would otherwise be hard to type, but let's tease apart some of the other things that top that function already. So it includes standard.io.h. It turns out that in C, a lot of the functionality that comes with the language is tucked away in separate files. So if you want to use this function, you have to tell the compiler, hey, I want to do some standard input and output, like I want to print something on the screen. And that's because for now, you can think of printf as living in this file, standard.io.h. It's a bit of a white file for now, but in standard.io.h is essentially a declaration for printf that will teach the compiler how to print things to the screen. So hash include here simply tells the compiler before it does anything else, essentially go ahead and find your local hard drive, file out standard.io.h, and kind of copy paste it there, so we know now about printf. So this thing, this .h file, is what we'll technically call a header file. And if you've ever heard this word, which is path programming for, it represents essentially what we're calling a library. So a library, in the world of programming, is just code that someone else wrote that you can use. It's usually free and open source, because you can literally see the code that someone else wrote, or sometimes you pay for it. Sometimes it's closed source, which maybe Microsoft wrote. They won't show you the code, they will let you use the zeros and ones. So libraries are super useful because honestly, even I don't really know how printf works. I've taken printf for 25 years to printf stuff that's on the screen, but someone smarter than me had actually write the code in C that figures out how to get the HDMI and so forth onto Mac screen, PC screen, phone screen, or somewhere else. So libraries allow us to sort of stand on each other's shoulders, and so they can help you do the hard work, and we can now solve problems that are more interesting to us. Not the a lot of stuff that everyone else might not know. So again, library is code that someone else wrote. A header file in C is just a file, and it is .h that gives you access to the same. And so for instance, if you want to learn more about these, there are what we're calling in the world of programming manual pages, and these are textual files like application source, violations, how a function works, or how you use input or arguments. The reality is they're really for folks who aren't in CS50, they're really for folks who aren't learning how to program, or in my case, who've been programming for years. So frankly, it's really hard to understand. So CS50 has its own version thereof, at this point, manual.cs.io, where you'll see not only the official documentation for C, the language, but also stack ranking simplifications and labels in terms of what all the various calculators are, what their inputs and what their outputs are. So for instance, under standard.io.h, you can actually go to that website, you can go to a URL like this, where standard.io.h is in there, and you can actually see the documentation there. So let's go ahead and do this. I'm going to go ahead and my browser here. I'm going to go to manual.cs.io, and go ahead here and select those functions that are frequently used in CS50. And under standard.io.h, you'll see a bunch of functions, only one of which we can discuss. I'll print that. I'm going to click on printf there, and you'll see an interface that at first glance might be a little overwhelming. It's going to start with more and more. So first of all, you'll see that if you want to use printf under synopsis, you need to include this header file. Like literally copy and paste that line into your code. You'll also see this, which for now is a bit arcane, but this is kind of a hint as to what the function is going to look like. More on that soon. But more importantly, you read a description about it. These descriptions, when you're in that comfortable mode, are written by me, of course, teaching about the CPS course system. You'll find something much more in layper's terms. So long story short, rely on the site if you want to learn how to use the function and also what other functions exist. In fact, if I go back to the main page here, you'll see that there are all these functions, like are frequently used in CS50, and there's hundreds more that come with C. But learning programming is not about learning all of those, but rather just getting a sense of where you find answers to questions when you do want to try something new. But what is important to know for CS50 today is that we have our own header file called csv.h, which has functions that we have written just to make life easier in the first few weeks of the class. These are training wheels that will eventually take off, but it turns out in C, especially if you program 4, it's actually really hard and annoying just to get input from users to get them to type a word or a number or something else. Like C does not make this easy, in part because it's one of the earliest languages that wasn't zeros and ones. So you have to do a lot of heavy lifting yourself. But we'll put on these training wheels today for a few weeks so that we can focus really on the interesting ideas of C programming. That way, I'll some things that we'll come back to before long. So for instance, if you don't have it there, that URL within the library, they are these functions. A function called getString, a string of text. String is synonymous with text programming. So getString will talk to you for string of text. Get is short for get in here. You want to get a number from you. Get load is real lowercase. Get load number, a real number with a decimal point in it, There are others as well. So this is to say within CSV, we've got some user-friendly functions by which we actually get some input. And let's go ahead and use one of them. For instance, getString. Because all that last week, our second programming scratch was this one here. Where we didn't say hello world, we said hello JD or hello Carter, hello Julia, whatever it was taking down the end. But to do that, we needed this ask block in scratch, and then use the save block, and then use the join block to make all of this work. So let's translate this program now to C. It's a little more interesting representative of the kind of code we'll start to write. But we need to bring this function here, which is the implementation code. We still have some inputs called arguments. But previously, I said the save block, and in turn printf as side effect, which is something visual typically that happens on the screen. Other functions actually have all that we return value. And this is kind of analogous to a function that is doing something for you, writing down the answer on the paper, and then handing you the program to the paper to do whatever you want with it without just broadcasting it to the world like a speech bubble on the screen. So a return value is domain for a program like this. Because recall, when you use the ask block, and I type in my name, where will my name end up initially? Didn't go on the screen yet, where did it end up? In an answer puzzle piece. And that special oval puzzle piece, I think, assigns a return value. So there's a metaphor piece of paper that the answer is written down on so that I can use it later. So that's what we want to get to now and see, a return value that I can do anything I want, whether it's the screen, change it in some way, save it in the database, or anything else. So here, for instance, what we do with trash, the input to the save block or the ask block was what's your name, quote unquote. The function, of course, is the ask function, and the return value was answer. If we now consider how we might translate this to C, it's going to look a little weird at first, but it's going to follow a pattern today, next week, after, anytime we decode like this. So getString, I claim, is going to be the most analogous function in C to the ask block. And to be clear, this is a specific thing, training wheels for, but we'll show you in a few weeks what this function is doing and how you cannot use it moving forward once you're comfortable with the language itself. Notice that parentheses left and right, sort of a placeholder for user input, and that user input is going to be what's your name. But I can't just put what's your name in parentheses, so I really need to add in there too. Yeah, so the double quotes left and right, so we can add those in. I like the space here, not for a new line. I could move the cursor to the next line, but I minimally at least want to move the cursor just one space over, just so it looks pretty, so that when I'm prompted for my name, there's a space between the question and my answer. But it could also be backslash n, just an aesthetic choice on my part. But what do I do with the answer that comes back from getString? This is where the text is going to look different. In C, you start to use an equal sign from left to right, respectively. And on the left, you put the name of the variable in which you want to store that return value. So a return value is kind of a conceptual thing. You can do with it what you want. If I want to store it, I want to return a variable like X or Y or Z in that class, I can give it a name, X or Y or Z, or more recently, answer, or any other English word. No spaces, generally lowercase things, here it is before, but this is now ask the user what's their name, whatever they type in, go ahead and store it from right to left in this variable called answer. But C's not done with us yet. You've learned Python or some other language, you've kind of done writing code at this point. In C though, you additionally have to tell the compiler what type of variable you want to use. So if it's a string of text, you say string. If it's an integer, a number, you say int, as we might have seen before. So it's a little more pedantic, it's more annoying, frankly, more honest on you and me, the programmers, but this just helps the compiler know how to store in the computer's memory. I'm so close to being done with this line of code, but what's missing? So semicolon. And mark my words, if you've never programmed before, sometime this week, this semester, you will get semicolon. You will like raise your hand, you'll get frustrated, you can't understand why your code's not working. You will run into stupid issues like that. They are stupid issues. It doesn't mean it's not clicking for you or you're not a programmer. It just takes time to see these things if it's a new language to you. So there now is my semicolon. All right, let's go ahead then and do something with that return value using the second of the big puzzle pieces in scratch. So when I wanted to say hello, comma, David, or whatever the name is, I kind of stack my puzzle pieces like this. This is actually similar to Python and some other languages some of you have learned, but C is a little bit different. And the closest analog to this scratch solution is going to look like this. I still use printf, because printf is equal to say, inside of my parentheses, I'm going to go ahead and say weirdly, hello, comma, %f. So there's no real analog in C of join. Instead, there's a way to specially format text using printf, hence the F in printf. And what you do in printf is type whatever English word you want. You then use %f as a placeholder. If you want a string of text to be added to your own text, you literally write %f. And let me answer this from the crowd. How do you print out %f? There's a solution to that text. You literally never want to print out %f. But it's deliberately a weird choice of characters, so that the probability that we would need to type this ourselves is low, and we don't really worry too much about it. All right, so that's not quite enough. In addition to saying hello, comma, space, placeholder, %f, and just for vocabulary's sake, that's a format code. Again, format being F in printf. I still need my double quotes around the whole thing. In this case, to match my previous program, I am going to go ahead and add \n to move the cursor to the next line. And now I've got a crazy amount of room here. That's deliberate. Does anyone have an instinct for what I'm probably going to want to add after the quotes, but still inside of the parentheses? So answer itself. I need to somehow tell printf with a second input, otherwise I'm going to use an argument, what I want to substitute for that %f. And so I put a comma and then the name of the variable that I want printf to figure out how to plug in here. So honestly, it's a little annoying, and it's kind of a data approach. Like newer, more modern languages, like we'll see later in the course, Python and JavaScript actually have much more user-friendly ways of doing it. But once you wrap your mind around the heuristics, the rules here, it's just formatting a string by plugging in whatever you want into this format string, so to speak. And again, the comma here is important. This signifies that it takes one input at left and a second input at right. But notice this comma. There's technically two commas, but I'm not claiming that this function takes 3 inputs. Why? This comma I'm pointing out doesn't mean the same. Exactly. This comma that I'm pointing to is part of the quotation marks, and therefore part of my string of English text. So this is just English grammar. This is sort of C syntax. And again, these are the sort of annoying little details that are using the same symbol for different things, but context matters. So just stare at your code, look carefully left to right, and generally the answer will pop out. Okay, questions now. And this is actually before we actually write it in Rust. Yeah. why is the backslash n not after the answer? So the way functions work, including printf, is that you pass to them one argument inside the parentheses, and then if you have a second argument, you put it after this comma here. But the way printf works is that its first argument is always a string that you want to be formatted for you. So anything you want printed on the screen has to go in those quotes. And you can perhaps extrapolate them. If I actually wanted to say multiple things in this sentence, so hello, maybe first name, last name, I could actually do hello, comma, %s, space, %s, if I had two variables, one called first name, one called last name. But then I need another comma for a third input to the function. And so it's very general purpose in that sense. Questions? Yeah. Okay, so can you extract away the format string itself? Hello, comma, answer? Short answer is yes, but not nearly as easily in C as you can in other languages. So that's why we're keeping it simple for now. But you're going to love something like Python and JavaScript, where a lot of this complexity goes away. But you'll see also in Python and JavaScript and other languages, they still are inspired by syntax like this, so it's understanding now will be useful for multiple languages down the line. All right, so let's actually do something with this code rather than talk about what it might be doing for us. Let me go over to, for instance, VS Code again, and I'm going to go ahead now and remove this middle line of printf. I'm still in my same file called hello.c. I'm going to clear my terminal window to eliminate distraction, and to do that I can literally type clear. This is just for aesthetic's sake, it's not functionally that useful. Or you can hit Control L to achieve the same on your keyboard. But I'm going to go back to line 5 here where I previously just said hello, comma, world, and I'm going to do this instead. I'm going to give myself a variable called string. I'm going to give myself a variable called answer, the type of which is string. I'm going to set it equal to whatever the return value is of get string, asking an English question, what's your name, question mark with just a single space, and move the cursor over, followed by a semicolon. Then I'm going to go ahead and say printf, quote unquote, hello, comma, placeholder, \n, close quote, comma, and then what's here again? This is where answer is. And then I see the semicolon on the right of that. So I can think now that I'm done. Let me point out a couple details. This got very colorful very pretty quickly. It's not like the black and white code I had on the screen a moment ago. This is because the program that VS Code do for us is it pre-prints, or rather syntax highlights our code for us. So syntax highlighting means just add some color to the code so that different ideas pop out. So you'll notice, for instance, that printf here, get string here are in purple because they represent functions, just like save block. Here, what's your name, quote unquote, in VS Code is like blue instead of white, but it's still going to be consistent. I use strings of text elsewhere as well. So I didn't type anything special. This isn't like Microsoft Word or Google Docs where I'm highlighting changing colors and things. This is all happening automatically, but it's just Unicode text. It's just being interpreted automatically and having the colors applied so that things pop out more usefully visually. Now, I've unfortunately made a mistake, but I'm going to deliberately induce this one. You too will probably make this mistake. I'm going to go ahead and run make hello again to change my code so I can regenerate the machine code from the new source code. But unfortunately, when I hit enter now, I've got my errors going to fit on the screen. So let me make it bigger. I'm going to click the little carousel here to make my terminal bigger for just a moment. And you'll see that there's like more lines of errors than there are code that I actually wrote. All of which is pretty arcane. Again, the programmers who've been writing code for 10, 20 years. But there are some details that pop out. So notice, the problem is definitely with hello.c. So great, it is my fault. This syntax here means that line 5 is a problem. And this next 5 means character 5. You can literally like triangulate your bug, your mistake, by going line 5 and over 5 and it's somewhere in that area. Specifically, the area is use an undeclared identifier string. Did you mean standard in? I don't think I did, but I do want string, and then there's some other complexity here. But what's important here is not the specifics of this error, but really the implication that it doesn't recognize the word string or get string. Now, why might this be? Yeah. Exactly, because we are using get string, which I think is a CSS thing that we use for a few weeks, C does not know about it out of the box, so to speak. I have to teach the compiler that get string exists, just like I taught the compiler that printf exists, by including the appropriate header file. And in this case, quite simply, it's called include csv.h. That now teaches the compiler, oh, someone else wrote this function already, get string, and with it this type of variable called string. So now if I go back to my terminal window and rerun the exact same command and make hello, maybe crossing my fingers, now nothing in fact goes wrong. So I was brought up to speed with all of the functionality we need. And now if I do /hello, enter, there it is. What's my name? And notice the cursor's one space over, just like that was prettier, and having the cursor right next to the question mark, DAVID as my input, and enter, and hello, comma, stated. Questions on any of this code thus far? Alright, so let's introduce some other functionality into the mix. It turns out that there are other types of data, other types of variables in the world, not just strings, but indeed, for before, we have them called integers, int for short, floating point values, float for short, and a few others as well. So rather than only focus on string, let's get a little more interesting with numbers here, and see what we can do with something like integers, again, int for short, by taking a look at not get string as before, but now how about get int. And for this, I'm going to give us a few other tools in our toolkit, those format codes, which I listed earlier, like %s, fortunately are pretty straightforward. Here is a list of most of the popular format codes that you might ever care about with printf. In particular, we call %s for string, and you can perhaps guess which one we're going to use for integers. So % I is what we're going to use for integers. And this is the kind of thing that you can consult in the manual pages for a slide like this. There's only a few of them that you might frequently use. But let's go ahead and use integers in more interesting context, not just using functions, but let's look at this idea of conditions. Conditions in fact relate to the real forks in the road. Like you want to do this thing, or this other thing, is a way of making decisions in the program, which is going to be super useful and pretty much omnipresent in any problem that we try to solve. So let me give you a few more building blocks in C by doing this side-by-side comparison again. So here in scratch is how we might say, if two variables, x and y, are one is less than the other, then go ahead and say, quote, x is less than y. So kind of a stupid program, which just shows you the basic syntax for scratch. This is how you ask the question, if x is less than y, then say this. So say the function, if is the conditional, and the green thing here, we call what? What about that? A boolean or a boolean expression. This is just a fancy way of saying the question's answer is true or false, yes or no, 1 or 0, however you want to think about it. In C, the code's going to look like this. So to take a little bit of muscle memory to develop, but you're going to say if, then in parentheses, you're going to say x less than y, assuming x and y are variables. You're then going to use curly braces, and then if you want to say, quote unquote, x is less than y, in C, what function should we use here? So printf. So printf, quote unquote, x is less than y. So it's a bit of an output, but again, notice the pattern. Name of the function is printf. In the parentheses, left and right is the argument of printf, which is quote unquote, x is less than y. And again, just for aesthetics, move the cursor to the next line. You don't have to worry about track, because everything's in speech bubbles. We're adding a /n as well. So notice that these curly braces, as they're called, much like the boring functions here, much like the functions in code like this. Now note that technically speaking in C, if you only have one line of code inside of your conditional, you can actually omit the curly braces altogether. Your code goes forward. If you have one single line of code, why? Just saves people from keeping. If you have 2 lines, 3 lines, or more in there, you need the curly braces. But I'll always draw with the curly braces in class so it resembles scratch as closely as possible. As an aside too, if you were programming before, you might be cringing now because you really like the curly braces to be over here instead of here. Like that's just a stylistic choice. We'll talk to you about this in class. Aesthetically, stylistically, there's certain decisions we can make, but generally in class, in a company, you as an student and employee, it's simply standardized on one set of rules, so to speak. So we'll use these rules for formatting our code in class consistently. All right, any questions on this snippet of C code? All right, well, so here is how we scratch. We might have a two-way fork in the road. If x is less than y, say x is less than y, else say x is not less than y. In C, it's going to look pretty much the same, but notice I'm adding else keyword here with a notice that's curly braces. I'm going to have a couple more printfs, but in C, even though it's clearly keyboard-based, it's just text, no more puzzle pieces, it's kind of the same shape, so to speak, and it's definitely the same idea, so it's following a pattern. What about a three-way fork in the road? If x is less than y, then say x is less than y. Else, if x is greater than y, say x is greater than y. Else, if x equals y, then say x is equal to y. We can probably see where this is going on the right-hand side. It looks almost the same. In fact, by adding a printf, it's really almost the same, at least logically. There is at least one curiosity. Seemingly a typo, it is not this time. Yeah, the double equal signs does not match scratch, but it's not in fact a bug or a mistake in C. Anyone have an intuition for why I did use two equal signs instead of one here? Exactly. Otherwise, we'd be mistaken for a variable, specifically assignment of a variable. So recall that in the previous code, when we used the getString function, we used an equal sign to assign from right to left the value of a variable. And that's a reasonable decision. Equal kind of means that the two should ultimately be equal, even though you think about it from going right to left. Unfortunately, authors of C could have taken themselves into a corner, and presumably decades ago, when they realized, shoot, we've already used this equal sign, how do we represent equality of two values? The answer they came up with was, all right, we'll just use 2 instead. And thus was born this decision. It's the best one who knows. Crazy enough, other languages like JavaScript have not just one, but two, also 3 equal signs in a row. This will be another problem. So reasonable people will disagree as to how good or bad these decisions are, but in C, this is what you must do. But there's bad design decision here too. It's still correct code, left and right, but I bet I can critique the quality of design of both the scratch code and the C code for reasons why. Okay, no, really good intuition. Do we have to ask this third question, else if x equals y? So short answer is no, logically, right? So based on arithmetic, if either x is less than y, or x is greater than y, or what's the only other possible answer, they must be equal logically. So technically, you're just kind of wasting the computer's time by asking this question because it already knows that that's the answer. You're wasting your time, the programmer, bothering to type out more code or more puzzle pieces than you need because logically one stems from the other. So I can tighten this up, get rid of the else if, just use else, and I can do the same thing over here in C, thereby avoiding double equal sign altogether, but not because it's wrong, but because you're wasting time. Because now you're potentially asking only 2 questions, 2 Boolean expressions, instead of 50% more by asking a total of 3 questions. Other questions then, on this kind of code. Alright, so we have these puzzle pieces, so to speak, at our disposal. How can we go about actually using these? Well, suppose we actually want to do something with values, let's introduce variables in C as well. So an example using a string a moment ago, but what about something like integers? We might not use this in Scratch, but here's an orange puzzle piece in Scratch by which you can create a variable called counter, count things, and you can set it equal to some value like 0. Now you can perhaps guess where we're going with this. If I in C, a variable called counter, and I want to set it equal to 0, I use a single equal sign, because logically, you read it right to left. Effectively, it's executing from right to left. But that's not enough in C. What's missing from the screen? I need a line. So we need a data type, it's going to be an integer, and we use
estou
so it's a little more verbose than some languages, but if you read it left to right, this is how you tell C to give you a variable called counter of type int and initialize it to a value of 0. So Scratch if you want to change that variable by 1 by adding 1 to it. In Scratch, it's super simple. You just change it by 1 or even negative 1 if you want to go up or down respectively. In C, it turns out there are a few different ways to do this. And this looks like it's not mathematically possible, but that's not because equals is a sign to recall. So this line of code is it's not saying that counter equals counter plus 1, that's just not possible using typical numbers, but this means take counter value, add 1 to it, and assign it back to the counter variable. So it's like increasing counter in this way. But this is a common thing in C and in programming to increase or decrease the value of a variable. There's a more succinct syntax. This is identical. It might take a little practice to get used to it, but it just saves you some keystrokes. But it similarly adds 1 or whatever number you use there. And this is such a common operation in C, especially that there's an entire way of executing the same idea, and you can literally just say counter plus plus, and then semicolon in this case. All three are exactly the same, all three are perfectly correct, but you'll learn over time that typing less on the screen is probably going to save you some time. Meanwhile, if we want to do the opposite and do something like -1 in Scratch, we can similarly do minus minus in C, or we can do minus minus in C here. Alright, so just some additional building blocks, translating from Scratch to C. Why don't we go ahead and try using this perhaps in the following way. Let me go ahead and go back to VS Code, and let me propose that we do something like this. In VS Code, I'm going to go ahead and clear my terminal window. I'm going to close hello.c by clicking X. I'm going to go ahead and create a new file called compare.c. My purpose is, like this program, is going to be to compare integers on the screen. This time I'm not going to mess up. I'm going to preemptively include csv.h. I'm going to preemptively include standard.io.h. And here too is a very common mistake in learning C. It is not studio.h. So when you email us asking why studio.h is not working, this is not the word. It is standard.io.h, meaning standard input and output, stuff involving the screen and the keyboard. Then I'm going to go ahead and just as before, in main void, but we'll come back to that eventually as to what it means. And now inside of main, which is just where the main part of my program goes, again, you can think of this being analogous to when green flag click. This just kicks everything off. I'm going to go ahead and do 2 things. I'm going to go ahead and get an integer called x, and I'm going to prompt the user for that int, and just say something like what's x question mark space. Then I'm going to do int y equals get int, quote unquote, what's y question mark space. And then let's just do something simple like if x is less than y, then go ahead and print out, quote unquote, x is less than y, backslash n close quote, semicolon. So it's not a very deep program, it's just going to do what most anything brain can do pretty quickly, but it's at least demonstrating how we might use now something like a conditional code. So let me go ahead and read, I'm going to compile this code for the first time, make it compare, enter, nothing bad happens, which is good, dot slash compare is how I run the program, and just to tease this apart, dot efficiency essentially means that the file is in your current folder. So dot means in your current folder, and we'll eventually see that dot means your parent folder, like the one that's contained wherever I am on my computer's hard drive. Alright, backslash compare was x, 1, 2 for y, and hopefully it should say that x is less than y. So pretty straightforward, proof by example, hopefully this will work in other cases too. But if I flip that around, and I rerun dot slash compare, and I do 2 and 1, nothing going to happen. But you expect that because there's only one Boolean expression that's deciding whether or not I should actually type this out. So what's going on, where this helps you, you might find that you want to think about the logic of any program, be it Scratch or C, as kind of like a flowchart of sorts, and we'll put up a few of these over time, just in case you're particularly visual thinker. And this represents what it is I just did. So here in this picture is where the program starts conceptually. And anytime you see a diamond, think of that as a Boolean expression, a question that's being asked. And the question being asked is x less than y. That has 2 possible answers, true or false, yes or no respectively. So let me propose for the arrow that if the answer is true, then print out for this rectangle x is less than y, quote unquote, and then stop. That's it for the program. But logically, if x is not less than y, that means that question's answer is false, we'll just skip right to the end and stop. So this is a control flow diagram. It's just a pictorial way of writing on this paper that just represents what it is the program is doing. And this is a little more interesting if now we do something else with the code. For instance, instead of just concluding that it's less than x, less than one or the other, let's go back to code here. Let me clear my terminal window, and let me add else. So else, go ahead and print out x. I don't think I want to say this. Greater than y. Not quite right. What would we want to say here? Yeah, it's subtle, but x is not less than y. It could be equal. We don't know. We're only checking two scenarios here. So if I recompile this, make compare, dot slash compare. Now if I do 1, 2, still get the same answer. If I rerun dot slash compare 2, 1, I now get the opposite answer. It's not as good as might be ideal. It's nice to know if it's equal to or greater than, but at least that's all the code that we have here. And just now for the picture, if I go back to my control flow diagram, the flow chart here, this is what it looked like before logically. Now that I've added in a second branch, so to speak, now if the answer is false, I first print out x is not less than y, and then I stop the program. So same idea, but the decision tree, if you will. If you take an x10 and like it's getting a little bit bigger. All right, we're going to do something more than this. Let's actually have that third condition. Let me go back to my code here. I'm going to hide the terminal window to make room for more code, and I'm going to say else if x is greater than y, then go ahead and say not x is not less than y, but rather x is greater than y. And then down here I'll go in else if x equals y, then I can go ahead and say printf x is equal to y, backslash n. Close the logo. All right, so now if I run it, let me open my terminal window again. Let me rerun make compare. Let me rerun dot slash compare. 1 and 2 are the same. Let me rerun it. 2 and 1 are the same. Let me rerun it a third time. 1 and 1 are now in fact equal. So this works correctly, but why did I make the point of using these else ifs? Put another way, couldn't I make my life a little simpler and just say if this, then that, if this, then that, if this, then that. Just ask all 3 questions, keep the code simple, fog these else's. Would this work for me? Yeah, so it saves a little bit of time, because in this case, just like in English, this is like asking 3 separate questions, and it's not harnessing any information from previous questions in order to decide whether you should bother asking that other question. In other words, if x is less than y, you already figured that out, 1 and 2 respectively, you're going to print this. Why would you waste time asking this question when it's not going to be true? Why would you waste time asking this question when it's not going to be true? So the point I want to make here, which is that if you visualize that particular design, what the flowchart looks like is actually this. And let me zoom in at the top. If you ask the question, is x less than y? Well, you're going to go ahead and say x less than y. Then if you go down to the next question, you're still going to ask, is x greater than y? And then below that, you're still going to ask, is x equal to y? So no matter what x and y are, you're asking 1, 2, 3 questions all of the time. But if we actually go in and do what we did the first time, we're going to go back to my code, and I undo this edit, add back else if, and now I go back to the flowchart, which I claim is bad, because 1, 2, 3 questions, 1 or 2 of which might not be necessary. Now if I visualize what I just did, the flowchart is a little more complicated looking, but it's going to be better designed, more efficient. Why? Well, because if I start at the top here, I add 1 question, x less than y. If the answer is true, okay, I say x less than y, and boom, I sort of cheat, go all the way to the end of the program and stop, having asked only 1 question. If though, x is not less than y, okay, fine, I'll ask the second question. But if the answer is true, boom, I print out x is greater than y, and then I stop. And only in a perverse case where x actually equals y, which I'm going to claim is very unlikely or infrequent, only then am I going to ask 1, 2, 3 questions to figure out whether or not to print something at all. So this is what we mean by distinguishing between correctness of code. It's so correct, this version is better designed, because hopefully you're going down this branch or this branch rather than along this one. Any questions now about this visualization error? Yeah. Perfect segue. Why did I bother even asking this question? Don't need to. When I hit the button, hopefully I have the right side in place. This would be even better than that design. Thank you for teeing that up. This is the same picture. It's got bigger difference. Fewer nodes, fewer shapes in the picture. Notice that if x less than y, boom, we say it's less than we stop. If x is not less than y, but it's greater than y, boom, we stop. Or if it's not greater than, then we immediately conclude x indeed is equal to y, and again we stop. So this picture is about as efficient and as well designed as you can make our logic. That's about as good as we can solve this problem. So if I go back to my code now to make my C code match that, the only thing I need to do is stop wasting the computer's time. Don't ask that third question. Just logically, mathematically conclude that of course it's going to be equal at that point in the story. All right, any other questions? Sorry, a little louder. Really good question. What if I put in something that's not a number? So here too is where the CS50 library and the implementation of the int will be your friend. So for instance, if I run dot compare and I want to compare cats and dogs, I can type in cats, enter. It's just going to prompt me again and again. It's not going to type in dogs either. It's going to force me to give it an integer. C does not do that by default. And in fact, as we'll soon see over the course of CS50, C is actually very dangerous language at the end of the day because it just trusts that the human is doing what he wants. And as such, a lot of today's software that is hacked in some ways, using C or another language called C++, are actually very vulnerable to certain types of hacking, whereas other languages that we'll get to in class are less for reasons like this. Alright, so besides this, let's consider just one other data type out. So besides string, besides char, there's some others on this list here. Sorry, besides strings, besides integers, there's this other data type here, seeing as a char, for a single character. So here we just tease this apart. A string is indeed a string of text. It is 0 or more characters together. A char is always precisely 1 character. Not always bother distinguishing between like a single character and a string of characters, but in C, a string is typically multiple characters. Technically 0, coincidentally 1, but it's capable of being more. But a char is literally, or implies, a single character. Alright, given that, notice that in the CS50 library, besides getString, besides getInt, we also have getChar. So another handy function is getting a single character from the user. Now why would you use it to get a single character from the user? Well, what if you're doing something that you frequently when you install new software or fill out some form, you agree to some form of terms and conditions. So in fact, we go back to the VS Code here, and let me propose that I create a new program called agree.c. So something akin to asking for user's agreement. So in VS Code, I'm going to type code, agree.c, and I'm going to use a quick boilerplate. So includes CS50.h, includes standard.io.h, int, main void, and then inside of main, which is like a green flag click, I'm going to do this. Go ahead and get a character from the user and ask them something simple like, do you agree? Expecting a yes, no response. But at the beginning of this line, I need to put the return value somewhere. So I'm going to put in a variable called c. And in programming, if you're just getting a single value, it's okay sometimes to use x and y or c. When you're using larger programs, you'll benefit from using actual words like answer, like we did from the get-go. But c has to be a specific type, so I'm going to literally say char, and then I'm going to finish my block with a semicolon. And here's now how I can check user agreement. I can do something like this. If the value of c equals quote unquote lowercase y, then go ahead and print out agreed backslash n. Else, if the variable c has a value equal to lowercase n, let's go ahead and print out, say, agreed. And so I'm agreeing or not some terms and conditions. But notice, these are not typos. What did I do ever so subtly different from last time I used text? Yeah. single quotes instead of double quotes. So here's a heuristic. When using strings, which are generally multiple characters, have to use double quotes. When using a single character, you should use single quotes around a single character. So let me go ahead now and make agree. Nothing went wrong, which is good. /agree, enter, and let me go ahead and type in Y for yes. It seems to work. Let me run it again. /agree, N for no, and it seems to work. And just if I type in something random like question mark, I don't know, it doesn't crash. It just ignores me because I only had 2 Boolean expressions there. But notice that it's actually a whole buggy arguably. Let me run it again. /agree, enter. How about capital Y? Like a half block away. Okay, it ignores me. Let me do it again. /agree, capital N, because my half block is down. Okay, it just ignores me. But this should make sense because I'm literally checking for lowercase. So how could I fix this? How could I fix this? Without just changing lowercase to uppercase, because that would break it in the other direction. Yeah. Yeah, so just add another branch here. So if variable c equals capital Y, then I can go ahead here and say printf agree, and then when we click on make more room. Otherwise down here, else if c equals capital N, let's go ahead and again say printf not agree, and I claim that this would actually now work. 4-way fork in a row, but I'm going to be checking for lowercase, uppercase for Y and N respectively. I claim that this is correct, but this too, even if you have a programming course, should start today to rub you the wrong way. Like, we can do better. This is the best design. Why not that be? Clever. So could we change the variable c to just be forced to uppercase or maybe forced to lowercase, no matter what you type? We can just do that ourselves. So that way we can just simplify this against 2 possible scenarios. I love that, but we haven't seen any functions yet in C that would let me change to uppercase or lowercase. So we'll get there. But we need to incorrect otherwise. So we can use or in some sense, like a logical or. Like what I don't like about this, to be clear, is that it's repeating itself. And like there's this principle in programming and like in general, like don't repeat yourself unnecessarily. By that I mean I literally have the same line 10 as 14. I have the same line 18 as 22. And if anything, I literally wasted twice as much time as I needed to. Put another way, per our discussion of Scratch, what if I go in and just change something like I want to be more excited, like agree? Well, I might forget to change it in the other place, and let's just claim for today's purposes that that looks stupid, it's a bug, because I want it to be consistent. So don't invite situations where you might change something in one place but not another. Just only write it in one place total. So I like this idea of oring things together. So let me go ahead and delete what I just did. And just to be clear too, while this is on the screen, when you highlight code in VS Code, based on how we configured it, these dots just show you how much I've indented. Because in C, stylistically, the convention is generally to indent 4 spaces and maybe 4 more spaces, so those dots just help you count without having to manually eyeball things yourself. But let me delete those lines, let me delete these lines, and it's going to look a little weird, but the way you can or 2 thoughts together, so to speak, like or them together, is you don't say or, but you use 2 vertical bars, which syntactically means the English word or, and you just ask the other question, if C equals quote-unquote capital Y. And then down here I can say or C equals capital N. So it adds a little more code to each of those lines, but it doesn't add redundancy, because I've not duplicated my printf. I've not added more curly braces unnecessarily. Now, as an aside, the opposite of or, logically, is the word and. Just so you've seen it, I could do this. Ampersand, ampersand, in C is how you express that the thing on the left must be true, and the thing on the right must be true. But why would this make no sense in this context of line 8? Yeah, like, at least to my knowledge, like, a character can be both lowercase and uppercase. That just makes no logical sense, so indeed, or is what we want in this case. Okay. A good question is, by a system without H0, we can compare strings. Short answer, no, but C is going to give us that capability. In fact, next week, one of the things we'll do is actually compare strings, and if you program before, you'll see in C that it actually doesn't work the way that you might expect. That's a problem too that we will solve. If that transcends C50, that's a question for C. Other questions on this kind of logic. Just to make this real, then, like, anytime you like click one of those ULAs or like terms and conditions on a form and things of software, like all there is code as simple as this, and then you click, maybe it's graphical, maybe it's checking for you clicking this button or hitting the enter key, but underneath the hood is presumably some kind of conditional checking for those kinds of aspects. Alright, how about another building block from last time? We'll not translate C, and we do things that happen again and again. These two are everywhere in code. So in Scratch, here's how we might meow 3 times. Super simple. In C, it's going to look a little weird, but you will get used to this over time if you've never programmed before. Looks like a mouthful. Okay, but let's tease it apart line by line, and you'll see that you won't have that reaction frequently, because it's all going to start to look very similar to itself. But what are we doing here? In C, you don't have the luxury of these cute and fun puzzle pieces. They just kind of do the work for you. Repeat 3 times. In fact, in C, and programming in general, sometimes the work is on us to actually figure out, okay, how can I use functions, variables, conditionals, and loops, and implement some idea, like repetition, like looping, and in C, here's how this might work. How can I go about doing something like printing meow 3 times? Well, I know about variables now, we're about to see loops, and I've seen how I can update variables by plussing or minusing like some value to them. Let's combine those ideas. So first, I'm doing what we just highlighted in English. A friend cares to ask you, like, what is this line code doing?
And you.
Good, it's creating a variable alt counter and setting it equal to 3. I'll use slightly neutral jargon. I'm defining the variable. Would be the term of art, alt counter and setting it equal to 3. All you hand represents a counter. And that's all very good. It's like storage in some case that I'm representing information using my hand in this case or computer's memory here. Now what happens when using a loop in C? There's a different types of loops, one of which is called a for loop, one of which is called a while loop. A while loop works like this. Inside of parentheses is a Boolean expression, just like inside of a conditional that asks you a question. But this time, the question is going to determine do you keep going through the loop again and again and again. So it's not a one-time thing, essentially. It is checked again and again and again to decide when it is time to stop looping, to stop cycling. Alright, so asking this question first, is counter greater than 0? Okay, obviously, the answer is true. We're still holding up 3 fingers. So what happens? C goes inside of the curly braces per the indentation and executes print up of meow, which prints out in meow on the screen. The next line of code executes, which we'll call is the same as just subtracting 1 from counter. So I think I take down 1 finger, so I'm left with 2. And what happens next? Well, this you just kind of have to memorize. Once you get to the end of the inside of a loop, you go back to the beginning of a loop here and ask the same question, the same Boolean expression. So is 2 greater than 0? Okay, obviously so you go into it, you print a meow, you go into it and decrement counter further by 1. So now my hand is holding up 1. Now we wrap back around to the Boolean expression, is 1 greater than 0? Obviously, we print out a third meow. We then decrement counter again, and my hand goes to 0. We go back around once more, is 0 greater than 0? No, and now the program just terminates, or if there were more code here, it would just jump outside of the curly braces and keep going lower on the screen. So that's all that's happening, and so this is what MIT has the luxury of doing with pictures, but at MIT someone probably essentially wrote code that looks like this to give us the illusion, the abstraction of this. So what we're learning today is sort of how they invented these puzzle pieces by just using lower level plumbing, if you will, like this here. Yeah? A really good question. What would happen if you created the variable inside of the curly braces? Short answer, it just wouldn't work in C, because if I were to try, with my slide here for instance, to move this line of code here down inside of this, for instance, now the very top line is trying to use counter before it even exists. So C is very literal. It reads top to bottom, left to right, and if it hasn't even defined or created a variable yet, you're going to get some scary error message on the screen instead. Other questions on this here code? user in a program whose sole purpose in life is to count, they'll just use I for integer, just like I used C for character. When you have larger programs, you don't want to start using A and B and C and D and E and F and so forth for variables, because nothing's going to make any sense. But when you're doing something super simple, like counting with an integer, using a short name variable is totally stylistically reasonable. But I can tighten this up further. Not just rename count to I. What else can I do? You recall? Okay. Yeah, sure. So, okay, for the yeah, well, in a while, I can tighten this up slightly more. Okay. Yeah, instead of I equals I minus 1, I can actually tighten this up this way. And we didn't see the minus before, but it's the same idea. I minus equals 1, or even more succinctly, I minus minus. So when you get comfortable with programming, any of these approaches are correct. This would be more conventional at this point. If you want to write code like most other people write code, adopt ultimately these kinds of conventions. Alright, so that just does the exact same thing though, but let's now put this into practice. Let me go back to VS Code here. Let me go ahead and clear my terminal and close agree.c from before, and let me go ahead and create a file called meow. So code meow.c. And let me do this the sort of wrong way. Let me include standard io.h at the top, int main void thereafter. Inside of there, let me do printf meow. And then you know what, I'm typing that, let me just go ahead and copy paste 2 more times. So I claim this is correct, make meow, / meow, done. I've got code that prints meow 3 times. But this again should already rub you the wrong way. Why? Yeah. Because I have duplication. I mean, I literally copy and paste, and that's kind of a good rule of thumb. If you in the future start finding yourself copying and pasting code within the same program, you're probably doing something wrong. There's a better way to design it, even if it's correct. So this is clearly a candidate for a loop. So let me go ahead and actually do that. Let me just go ahead and remove all of this duplication. Let me give myself a variable called I, set it equal to 3. Let me go ahead and give myself a while loop and check that I is greater than 0. Inside of this loop, let me print out just meow once, but I'll reuse that code again and again, because here I'm going to do I minus minus. So that's the exact same code, the type version of it that we saw a moment ago. Let me go ahead and make meow again, / meow, and it still works. Why is this version better? Because if you want the cat to meow 5 times, you change it in one place. If you want to make the cat a dog, you change the meow to a whoop in one place, albeit changing filing eventually, but changing it in one place, not worrying about changing it again and again and again. But there are other ways to do this. For instance, let me propose that, and actually, let's see, let me propose that instead of just doing it this way, just to be clear, yeah, let's go ahead and propose that instead of doing this, we can actually count in different directions, right? I'm kind of forcing this idea of starting at 3, going down to 0, but when normal humans in this room, if you ever count something, you probably 1, 2, 3, and done. Like that's how you count in the real world. Well, we can do that too here, code-wise. We could initialize I to 1. We could check that I is less than or equal to 3. And we've not seen this syntax before, but there's no easy way on typical keyboard to type a less than or equal sign like in a math book, so we use 2 pairs, a less than sign, and then an equal sign, back to back, and that means less than or equal to. And this is the same idea, so long as I put plus I inside of it, because that'll change start at 1, then 2, but it won't stop then, it will go up to until I is equal to 3. Once I becomes 4, then that Boolean expression isn't going to be true, so it stops after 3 meows total. But there's another way too, and this is probably the most conventional and the way you should do it, even though it's just as correct. In CS, as we've seen already last week, you don't always start counting from 0. Why? Just because you're not wasting a pattern of bits. So generally, when you start writing code that counts, you should, quote unquote, almost always start at 0, count up to, but not through the total you care about, so you get 1 extra by accident. And so this would be the most conventional way of doing what we just described. They're all correct. You can make an argument that all of them are equally good. This is what most people would do. Okay, let's hear it. Syntax or logic. All right, how about, we've got cookies on the horizon. Before we get there, let's meow a few more times if we may. So how about doing a little bit differently versus the while loop? And I think we're going to over here. Turns out there's another type of loop altogether. So this one here, and this one, if you can believe it, is probably even more conventional than the other way. And this is going to be thematic in programming. Like there's rarely one way, one right way to do things. You're going to have bunches of different tools in your toolkit, and your code might be different from someone else's because each of you tends to reach for a different tool in that toolkit. If here's another tool, and you should, as we proposed earlier, a for loop. A for loop is just another way of doing the exact same idea using slightly different syntax, and it's appealing, frankly, in general, because it's a little more succinct. It just saves some keystrokes, even though you have to memorize the order in which it works. This code is identical to this code here. Functionally, but aesthetically, of course, it looks different. How does it work? In a for loop, notice that in parentheses, not a single simple Boolean expression, there are 3 things. 1, before semicolons, is a place to initialize a variable to do your counting typically. Second is the Boolean expression, so it's still there, it's just surrounded on the left and the right by 2 other things. Lastly is update. What do you want to do at the end of every loop through this block of code? So you can probably imagine where we're going with this. How does this work? The first thing that happens is that a variable called I is defined and initializes the value of 0. That happens once and only once. Then we check the condition. Is 0 less than 3? Obviously yes. So now we don't do the plus yet. We go into the loop. This is where the code was a little confusing at first. We print out meow. Then what happens? There's no more lines, so we go back to the for loop and we increment I at that point. So now I is 1. Then we check the condition. I is less than 3, yes, because 1 is less than 3. We go back into the loop and print meow. Now we go back to the plus plus, so I is now 2. We check the condition. 2 is less than 3, obviously, so we go back into the loop and print meow. Then we do the increment. I is now 3. Is 3 less than 3? No, so we exit the loop, and we're done, or we keep going down here if there's more code. But how many times did I say meow? 1, 2, 3 total. When my hand was 0, 1, and 2. Question. On this alternative syntax, I take it get YouTube, but most people write loops using for loop. Yes, if you really want to be cool with syntax, yes, it is correct and common to eliminate the curly braces if you only have 1 line of code therein. We in class will always put the curly braces there. This is the kind of thing where if you get the demo, go in later and have a second line, like darn it, I forgot the curly braces, things will not work as effective. So in general, use the curly braces. You do not have to. Other questions? One second, yes. Can you use that one? Oh, could you do it without the condition? Yes, there are very fancy things you can do that we won't focus on today, but yes, if you want to get rid of the condition, you can get rid of this here, and that would actually make the loop go forever. Which may be a good thing, it's like a clock that you want to take forever, but often not a good thing. Alright, so beyond that, let's just go ahead and put this into context just in case it helps you think about this. This is just another flowchart, if you're more of a visual thinker, that represents what it is this loop is now doing. Previously, all of our arrows went from top to bottom and stop, but now there's an arrow going back up and around because of this loop, this cycle. So when we start this program, we set I equals 0, we then check this is I less than 3. Obviously it is, so we print meow, we increment I, and then we go back to that same condition. We check the condition, we print meow, I plus plus, go back. Now if I equals 3, 3 is not less than 3, so the answer is false, and we stop. So again, it's just another way of thinking about how the code is tracked, how the code is seen, might alternatively work in each of these contexts. But there's this one other puzzle piece of scratch recall that's number key block, which is for finite numbers of repetition, but forever. And in C, there is a way to do this, but it's a little weird. There's no forever keyword, but you can use the while loop, or as you can do, you can actually use the for loop without a condition in the middle. So here, I can actually say this. If I have 1, 2, 3 forever, I want to make sure the answer to my question, the Boolean expression, is true, the easiest way to achieve that goal is just like literally write true there. Because true is true no matter what, and it's a trick for making the loop forever go around and around, as you might want to catch and live forever, meow, endlessly, or if it is clock, you want to tick forever or away. So here, for instance, is how we might have a cat meow endlessly using the so-called for loop instead. But recall that in Scratch we also have this ability to create some of our own puzzle pieces, and this too is something that we're going to be able to do here in C. And let me propose that we do exactly that by introducing the C analog of this. So here, for instance, is in Scratch our definition of a function called meow. The sole purpose in life is just play this out meow until it's done. This is going to look a little weird at first, but you'll notice some similarities with main. So recall the thing I typed in main, main void. That's just the when green flag click equivalent for today. But if you want to create your own puzzle piece or your own function in C, you for now literally do this. You say void, the name of the function you want to create, and then void in parentheses. And technically what this means is that this function has no return value. It doesn't hand you anything back like get string or get ends. And the void in parentheses means it takes no inputs. It only meows. You don't have to tell it how to meow, it's just going to meow. So no arguments, so to speak. This literally just prints out meow. But what this does for me is it abstracts away the idea of meow. I don't need to know how to use printf or that you're using printf to make it cat meow. I now have a function in life called meow. Because in Scratch, recall, I use it like this. When the green flag is clicked, I can repeat 3 times this new custom puzzle piece. But in C, I can now do this. In my main program, I can use a for loop, just like we saw a moment ago, copy paste it from earlier. But now I can call my own C function called meow. And let me go ahead now and do this. If I go over to my C code here, back in VS Code, let me go ahead and delete everything inside main. Let me go ahead and do for int I equals 0, I is less than 3, I plus plus. Inside of my curly braces, let me go ahead and say meow, but I now need this meow function to exist. Because if I do make meow again, notice error. Implicit declaration of function meow is invalidated C99, 1999 version C. What does that mean? Well, it doesn't know what the meow function is. And the meow function is not in CSS.h, it's not in standard.h. I have to create it. So let me type out, or let me copy paste what I had on the screen a moment ago. Void meow meow, void meow void, printf, quote unquote meow, close quote, semicolon. But here too, let me scoot this down a bit, so you can see all the code at once. Let me now do make meow. Unfortunately, I still have an error. If I scroll up, still on line 7 of meow.c, my compiler thinks that meow is not invalid, that it does not exist. This too is a common mistake, and as simple as this code might be in spirit, where did I screw up? Yeah, a minute. Yeah, I need to define the function before I use it. Again, C is going to take you literally. If you type all meow on line 7, you better not define it on line 11, you better define it higher up. So the simplest fix is going to be just to do this. Let me clear my terminal, let me highlight and delete meow function, and let me just paste it up here. And this will actually solve the problem. Make meow now works, and if I do dot slash meow, that too works. But this isn't really the best solution because your solution is constantly always put it up there, put it up there, put it up there. I definitely can try the situation where one function needs to be above the other, but it needs to be above the other. It's not going to work in general. And more importantly, it just pushes main lower and lower and lower in your file. But the whole point of your main function is like that entry. Like that is what happens when the green flag is clicked. And so just in terms of user prevention, it's just useful for main to always be at the top of the file, because you can find it fast. Your friends can find it quickly if it's at the top. So the other solution here would be to leave meow at the bottom and leave main at the top, but this is the only time, if I made it, copy paste is okay. What I've highlighted here in line 11 is what's called the function's prototype. It is enough information to give you the return type, the name of the function, and the return value, and the arguments. And so if you just copy paste that one line and if it's semicolon up there, that's enough of a hint to the compiler. Okay, it doesn't exist yet, but it will look like that. That's the only time you'll get a copy paste the very first time the function you bring in to the top of the file with a semicolon so that you can make the compiler happy. So if I do make meow now, still no error, dot slash meow, and it now works. But let me add one final feature, coming back to Scratch here, and then it's time for a snap. So here, recall, sort of the last fancy thing we did in Scratch, where we created not only our own puzzle piece, but it took an input, so that we didn't get confusing the loop ourselves, we could just let the meow function be told how many times we want the cat to meow. So in C, we don't have to make that many changes, except this. We changed the prototype to take an argument inside of parentheses, and this is the syntax for that. If you want your own function in C to take one more argument, you give the argument name, n, or whatever you want to call it, but you have to tell C what the type of that input is, so it's an int n, so it knows it's a number, and then you can just use n in your program. So instead of hard coding, typing manually the number 3, I'm just using n here. So this is equivalent to what I did in Scratch, I just drag and drop n variable there, and then now we printed that many times. If I want to use this, notice this is the last version of the cat that we did last week. You just say meow this many times. So in C, this is where now the code gets very succinct, because all the main part of the program does is meow many times. So this again is abstraction. There's no care or remember how meow is implemented. I just need to know what its return value is, name, and the argument there too. So if I make this change, I think we can get the cat meow a number of times. Let me go back over to my C code here. Let me go back into the file and change void here to be int n, where n just means number. I could use I and n to be a function instead of a counter. I then inside of this function, I'm going to do a for int I get 0, I less than n instead of 3, I plus plus, and inside of here, paste that meow again. I need to change my prototype to be identical, so another copy paste, manually edit it. But now notice what's cool about main is that now I can meow maybe 3 times. Make meow, enter, dot slash meow. Okay, or if you really want to be cool, you can do this like 30,000 times. Go back here, make meow, increase the size of the terminal window for dramatic free break first, and there are 30,000 cat. There are 30,000 meows. I think now let's go ahead and take a 10-minute break. We'll see you in 10. Cookies are now served outside. Alright, so we are back, and I realize this isn't a lot so far, right? So there's a lot of syntax, there's a lot of translation, Scratch, and C, but among the goals of having spent last week in C, in Scratch, and having spent problems out with 0 in Scratch, is that like none of today's ideas are really all that new. There's a lot of syntax you do get more comfortable and more in your memory as time passes. Up until now, though, we focused mostly on these side effects, like things happening on the screen. That was going to be a couple here in the world of Scratch. But let's focus for just a bit before we then explore things we can't do very well in code, return values instead in C. See, no matter what, get string returns value, get int returns value, string and int respectively. But what if we want to make our own function that doesn't meow, usually have the side effect of meow and speed, that actually hand us back some value. Like that we can do this in C as well. Well, let's propose that to go that route, so we go back to this code here, here's our very simple calculator, like add some numbers together. But the same calculator, since he's going to get us into trouble, you don't understand what the computer is doing underneath the hood. Let me go ahead and run code, let's say calculator.c, and in here, let me go ahead and give myself access to to the CSS library, .h, standard IO library, standard IO.h, int main void, which again we'll just take for granted today that you have to include in each program, and let's just add two numbers together. Super simple calculus. So give me a variable called x, assign it the return value of the int, and I'll ask the user to give us x. Give me another variable called y, assign it the return value of the int again, and this time ask the user for y. And then lastly, let's just go ahead and print out the value of x plus y, but I don't think that I can get away with something like this, x plus y semicolon. If I do this based on what we've seen before, what's actually going to get printed out? Right, literally like x plus y. So I think this is where I can in printf formatting, but I think I really want to do is print out the value of some placeholder, because what do I want to substitute for %i? Maybe as a second argument to printf intuitively? Maybe just x plus y. So indeed I can get away with this, because printf and C, there's a bunch of arithmetic operators, all the ones that you might expect, including addition, subtraction, multiplication, division, and even this one, a modulo operator, which generally gives us the ability to calculate a remainder when you divide one number by another. But I'll keep it simple with addition, and indeed with printf, if I want to print out the value of x plus y, I can do that, but I have to tell printf what kind of value to expect, an integer, thus the %i instead of %s for string, and I think they should do the job. So let me go back to my terminal, make a calculator, enter, all is well, so dot size calculator, let's keep it simple, 1 for x, 2 for y, and indeed, I get 3 as the output. It's not very dynamic, it can't do a subtraction, a multiplication, or a 4, but it does these two, those kinds of calculations. But let me propose now that we maybe make a reusable addition function, right? Because addition is something you're going to do a lot, and maybe it should be abstracted away from functions, just like now was abstracted away from go. So let me go ahead and instead of doing this, let me go ahead and give myself a function called add, but instead of last time, where I had a now function, I'm obviously going to call this add instead. And instead of last time taking no argument, I think I want add to work a little differently. I don't want add necessarily to take an argument yet, I want add to return some type of value. So like, what type of value should an addition function return? An integer. So again, so I'm going to change void, which means the absence of a return value. Nothing's coming back. You literally can't. But I'm not going to change the thing inside parentheses yet. I'm going to go ahead and copy my prototype up here, and I'm going to make this change, return x plus y, and then here, instead of printing out x plus y, let's go ahead and do this. I'm going to give myself a third variable for now, z equals the return value of the add function that's going to add x plus y for me, and then let me set that value to z. Instead of x plus y, I'm outsourcing now this add function, so it will do the addition of x plus y. So similar in terms of meowing, but the return value, like we're about to create addition, so let me make a calculator again, and there's definitely some errors. So here we are, use a undeclared identifier x, and that's on line 17, so that's pretty far down the line. So specifically, my compiler doesn't like the use of x on line 17. Wait a minute, x is clearly defined on line 8. What intuitively might explain? Yeah, because it's why we're finding the main function, not in the add function. So the term of art here, we're about to introduce something called scope. So scope just refers to the context in which variables exist. Context in which variables exist. So if I take that out of this, on line 8 I declared x, on line y I declared, on line 9 I declared y. But the patches, the curly braces are helpful. Those variables only exist in the context of the outer curly braces that are nearest to them like this. So I can use x and y on line 10, 11, 12, and even up to 13, but not thereafter. So I certainly can't use x down here on line 7. But this is a problem, because the add purpose is add x and y, but add can't access x plus y, well, we have actually scope. Like x and y are not in scope for this add function. But that's okay, because remember that every function you've seen thus far can have maybe a return value or a side effect, but it can also take 0 or 1 or 2 or more inputs, known as arguments. So what if I instead do this? Let me clear my terminal window, and then we update add to not take nothing as input, but maybe 2 integers. And I'll call them arbitrarily a and b. But I have to tell the compiler what type of arguments they are. 2 integers, one after the other. And now what I can do is this. Let me change this up here too, int a, int b, just so the prototype is exactly the same. And the only purpose of this prototype is to avoid previous error, where the compiler didn't realize add was going to exist, particularly later in the file. So here on line 11 now, if I want to add two values, x and y, this is now the syntax. We saw syntax in strat, we're passing input, so it's how many times can out. So this is just telling add what two numbers to add together. So now I have to change this to a plus b, for reason equals to c, and make this right, make calculator. So far so good, dot slash calculator. Let's do 1 and 2 for x and y respectively, and hopefully we should again see 3. Now what's going on? So here again, if I zoom in on my add function, this int here on the left, on line 13, means what about add? This means that it has a return value that it's going to hand back and forth with a paper with an answer on that is a type integer. It's not a word, it's my name, it's a number instead. These mentions an int here and here are inside the parentheses, which means this function add takes 2 inputs. The first is an int, the second is an int, and just so we have something to call them, I call them a and b respectively. So what happens essentially, when I call the add function now on line 11, I'm kind of passing in x, I'm passing in y, but the add function is going to think of them as a and b respectively. It can call it anything I want. I can change this to the word first and second, and then I can literally change this to first plus second. Those are perfectly acceptable as argument or variable names, but who really cares? Like a and b is such a simple function, it's perfectly reasonable too. Technically, if your mind is going there, I could even call them the exact same thing. But let me propose for today's purpose, don't do that. It's confusing thing. You've got x and y here, x and y here, but they're clearly different. Just don't do it. Try to come up with different variables just to keep yourself sane. But here, I have a function that takes out 2 integers, a and b respectively, just returns the sum of them, so that I can now store the return value add in a variable called z, and then quite simply print it out. There's one other thing I can do here. Now we're thinking about design. Even if you've never programmed before, do I really need the variable z? Because I'm defining it on line 11 and I'm quickly using it on line 12, and like that's it. Like sometimes you don't need variables. They might make it more readable, but strictly speaking, and this is kind of like substitution in math, if z is the same thing as add x comma y, well let me go ahead and delete line 11 altogether. Let me get rid of mention of z. You can actually get away with doing this. And much like the join block in strat, where I can overlay the say block, like kind of stacking them, you can stack functions and see or guess them really mathematically. Honestly, it makes it a little harder to read because your mind can kind of dive into steps deeper and deeper into this second argument, but it's perfectly acceptable too. And just to connect the dots, maybe something from high school, this is kind of analogous to a function in math class being like f of x, f is some function name, x is some arbitrary input to that function, and when you start to put functions inside a function, so that the output of one becomes the input to the next, it's like using this syntax, f of g of x and so forth. If you've never seen that before, don't worry, but if you have, it's a way to connect some of these dots. Any questions on just this idea of now having a function that doesn't have a side effect, but instead has a return value? Yeah. In our definition name, what I request? Oh, really good question that I'm trying to sweep under the rug for today. But in every one of our programs thus far, I have indeed said int main void. Technically speaking, whenever you write a program and it finishes running, it actually returns a value somewhat secretly. It returns the number 0 by convention, which means all is well, and it can return any other integer if something goes wrong. In fact, on your Mac, PC, or your phone, you've never gotten like a weird message on the screen, like something wrong, it's like a weird numeric code, like 0, -1, 29, something arbitrary like that. That tends to mean that some program running on your Mac, PC, or phone had something go wrong with the main function, and that is the number that was returned. But that's more than we want to talk about today. We'll come back to this. But main always returns a number by default. It is 0. More on that. Alright, so with that said, let's actually tease apart what it is we've been using underneath the hood here a little bit by returning to VS Code interface itself. It turns out that all this time, like people alluding to macOS and Windows, which like 99% of us are probably running on our laptops or desktop, there's actually other very popular operating systems in the world, one of which is Linux. So Linux is a very popular operating system, the thing that turns on, the thing that boots up when you first turn on a computer, and it's very commonly used for servers. Nowadays, all the systems own servers run some version of Linux. Those students more comfortable sometimes run Linux on their own Macs or PCs even. So Linux is a very popular operating system, and it's particularly characterized by its textual interface, its command line interface, even though it also comes with graphical ones as well. So again, this term we started today with graphical user interface, this thing with menus and buttons, it's literally what you use every day on your device, otherwise you use a GUI. But today on, we're getting more comfortable with and more practice with this terminal window down here, which represents a command line interface or CLI. And just so you have a mental model of what's going on in the cloud here, when you access CS.dev, you are accessing this version of VS Code in the cloud, piece of software that's running in the browser. But that piece of software is automatically connected to your very own personal server in the cloud. So technically speaking, it's a Docker container. But it means that you have just your own mini server in the cloud that only you have access to. And that server or container is running an operating system called Linux. In fact, every time I've been running a command down here, whether it's code or make or /hello or anything else, I've been running commands from here in Center Speaker or server somewhere in the cloud, my own Linux container or server, and you'll have the same yourself. This is the thing that we have pre-configured for you by installing the compiler and so many other pieces of software you'll soon see in the class. But underneath the hood then of Linux is a soon familiar environment that allows you to run different types of commands. And those commands include things like this. And this is something we've developed on for over time. I want to give you a sense of some of the most popular textual commands. Because we're essentially about to take away some of what you have from a GUI world and have you type out words that represent double-clicking on things, dragging on things, and other sorts of commands you might take for granted. It'll be a little painful at first, the first days or weeks, but it will make you far more productive long-term. So that even after CS, if you start doing programming skills in some other domain, class, or real-world job, you'll just be a lot faster at the keyboard and able to do more work more quickly. So with that said, let's go back to VS Code over here. I'm going to open up my file explorer over here. You're going to see I have all the files that I've created thus far in class, all of the programs that I've compiled thus far in class. I also have the source one directory, which you can download from the course's website, which has all of today's code pre-written in advance. You can type everything that I literally type, but all of these files are things that I've created. You see that in white are the files, and grayed out are actually the binary files, the machine code that I created that I've running. So you can click on any of these files in VS Code to open them. For instance, here is hello.c, and voila, it opens in the text editor. But if I try to open hello, that's not going to work because that's zeros and ones. And frankly, the computer could show all those zeros and ones, but it's just not going to be useful. And honestly, it's too easy to make one mistake and break the whole thing. So instead, VS Code says that it can't display the text because it's binary, or maybe it's supported more generally. So know that you want to only click on .c file or .c code. But let me go ahead and do something else. Suppose that I decide that wait a minute, we're near the end of class, we're not going to change hello.c to goodbye.c, or if I'm changing now.c to whoop.c, it's not well, let's actually do that. I could go over here and right-click or control-click on the file, just like on a Mac or PC. I can find the rename option and I can do it all via the GUI. But you should get more comfortable using commands like these here. And among the commands on this list are mv for move, aka rename. So for instance, if I want to change now.c to be woof.c instead, I literally type mv space, the original file name space, and the new file. So this is very similar to what I've already been doing with the code program or the make program. And I'm going to type the name of the command, but also the thing that I want to code, the thing that I want to make. In this case, I type the thing that I want to move from old to new. Now, if I can enter a moment, watch on the left-hand side, now.c in the GUI should automatically change, even though I'm doing this all via the command line keyboard interface. And now it comes whoop.c. Right, it's not all that exciting. This is just to say that they are one and the same. One is a GUI, one is a CLI, but it's the same exact thing. Moreover, we can close now the GUI app, the so-called Explorer. And in my terminal window alone, now I'm kind of having the wait a minute, this file I created earlier. Well, there's other commands as well. On this list is coincidentally ls, which lists the command, lists the file in your current folder. And as you might have here, mv for move, ls for list, like CS people like these things, terms, and type the minimal number of keystrokes, that's why these are all abbreviated commands instead of full word. But if I go back to my terminal window, type ls, voila, there is exactly the same content of my server, but displayed textually. And there's some heuristics here. In green with an asterisk is all of the programs that I made with me that are executable. So the asterisk is executable / Meanwhile, the source one directory, which only I have because I downloaded it in advance, has a slash to indicate that it's a folder instead of a file. But all of these white files ending in .c we created together here today. Now, what if I really am embarrassed by my very first program, hello.c? Well, I can very disruptively go and use the rm command for remove. And rm, hello.c, is going to prompt me, a little cryptically, remove regular file, hello.c. And amazingly, this rm program has code just like we wrote earlier for agree.c, where I can type y to delete it, I can type n not to delete it, but let's delete it. Let's go ahead and hit y, enter. Nothing seems to happen, but in general, that's a good thing. But if I type ls again, notice what is now missing. And in fact, the list is a little shorter, so it's 1 line instead of 2. Hello.c is now gone. Now, if you do that, there are not easy ways to get the file back, so don't do that unless you really want to. But there are backups maintained in these files as well. Well, what else is there too? Well, there's all of these other commands you'll experience them over time, like cp is copy, mpdir is make directory, rmdir is remove directory. And for instance, let me just show you one folder. If I type ls, there's that source one folder that I claimed I downloaded in advance. If you want to see what's there, you can type cd for change directory, source one, enter, and voila, notice that your prompt has now changed. And let me clear the screen, just as a visual reminder of where you are. You can see before the dollar sign now that in the folder that you're inside. So in Mac or Windows, you see obviously a graphical folder. Here you just see a little textual reminder of where you now are. And if I type ls, I see that I wrote a crazy number of files before class, and each of these represents different versions of the files. I've been coding here in real time, but I usually have printouts of them to go through things in series, so you have copies online as well. So in short, all of these commands, if you've never used them before, they will soon become like muscle memory and they do the most basic of operations, but there will be other commands that you'll see over time that do even much more than that. But let's go ahead now and solve some actual problems. And it's no coincidence that it keeps showing we're alluding to Super Mario Brothers and some foreign older game on Nintendo Entertainment System that allows you ultimately to have this two-dimensional world where Mario is up and down and side scrolls from left to right, but you'll see we can distill even some aspects of Mario into some fairly representative programming problems. And in fact, let me propose that we consider this screen from the original Super Mario Bros. So there's these four bricks of blocks in the sky into the question mark, and if you click on one of these, you jump up Mario, jumps up underneath each of these question marks, he gets like a coin or something else that pops out. Let's distill this though into its essence and consider and see how can we make not a blue sky yet, not a green grassy hill and so forth. How can we just make 4 question marks in a row? Because I dare say that we do have the building blocks by which to do this. Well, the simplest way might be to go over here and run code Mario.c, and then in Mario.c let's include standard IO.h, we have printf, let's do int main void, let's keep doing inside of main, let's keep it super simple. 1, 2, 3, 4 backslash n. Doesn't get much simpler than that. It's not going to be the prettiest game, but if I make Mario now, dot slash Mario, I get my 4 question mark in the sky. Alright, so it's not all that interesting. This is clearly a candidate for the programming feature. Not to scratch, but I'm going to get more interesting. Yeah. So some kind of loop, right? So I'm printing out iteratively instead. So let me do that. Instead of just printing this out all at once, let me go ahead and remove this before. Int I gets 0, I less than 4, I plus plus, and then in here, let me go ahead and print out just 1 question mark instead. And now let's run this. So make Mario, we compile it, dot slash Mario, and then not more than enter your X, Y. Yeah, it's going to print a new line every time. So notice, it's 4 question marks, but they're on each on its own line, right? Let me fix this, obviously because of the backslash n. So let me remove that. Let me rerun make Mario, dot slash Mario. It's better in one way, but worse in another. So wait, but now the dollar sign is going to be the same way for the same line, it's just stupid, anything else. So how can I fix that? Yeah, so obviously we don't have that many building blocks. A lot of these things, it's not that many new ideas. Let's just use printf to print out literally 1 and only 1 backslash n to add outside of the loop. So it happens after all 4 of those have been printed. Alright, we're going to make Mario again, dot slash Mario. Now we're back to business. So sort of silly syntactical details, but if you reduce the problem to its essence, it should hopefully logically be clear over time. Alright, we're going to something that vertical. We've done something vertical already, so I can actually change the program very soon to out 3 bricks instead of 4 question marks. But what if we consider a 2-dimensional world? Later on in the change, go underground, everything will lots of bricks. Let me propose for the sake of discussion that this big wall here is like a 3 by 3 grid of bricks. So it's a single brick, it's like 3 by 3 in total. Now things get interesting. And let me go back to Mario.c. I kind of take the easy road out and say, alright, let's print out printf about 1, 2, 3 backslash n close quote, and then okay, not be paste, and using hashes instead of the actual bricks. That's pretty close. Let me now go ahead and make Mario again, dot slash Mario. It doesn't quite look like a square, it's just the hashes are a little taller than they are wide, but it's correct, but not well designed. So here too, what would be better designed than just hard coding, typing literally all of these hashes. Yeah. Interesting. 2 loops. Why 2 loops instead of 1? Okay, so so 1 vertical, 1 horizontal, even though these predicate so much, like old school typewriters might know what we call that piece of paper, so you sort of print like line, then it scrolls, line, then it scrolls, line, then it scrolls. This is kind of how the terminal window works too. You print rows or columns, but you have to have 1 row at a time, 1 row at a time, 1 row at a time. It's not easy, but it is possible to like go backwards or sort of up and down, but it's only 1 row by row by row by row. So how can I do this? Well, I can use at least 1 individual 2 loops. And this is where we're just now proposing different ideas for today and even last week. So let me go ahead and say for int I gets 0, I less than 3, 3 by 3 grid, I plus plus. And now let me cheat slightly. Let me print out 3 of these here, and that's it. I'm kind of cheating, printing out rows dynamically, but I'm still printing 3 columns all in one row. But let's see what happens. Make Mario, dot slash Mario, and it does work. But what if you said I want 4 by 4, or 5 by 5, or 6 by 6? Now I have to change like 3 to a 6, and I have to add another 3 hashes here. Like, things get messy if you don't do this mathematically. So let me now do this instead. Why don't I go ahead and print out every row at a time? But for each row, let me use another loop to decide like, from left to right how many do I want to print. So to do this, I can do another for loop. I can call this something different. J, pretty common. Sorry, I go to J. If you go past K, maybe L is probably doing something wrong. You don't want this loop, but 2 is okay. J equals 0, J is less than 3, J plus plus. And then here I can print out a single one of these. And no new one. I don't want to screw up like I did before, so I'll just do 1. Let me go ahead and do make Mario now. Dot slash Mario. Can I hit enter? It's not correct yet. It's going to look like a single line of 9 hashes, I think, because I never use a single backslash n, so that's wrong. So on what, between what line number should I insert a printf of a backslash n? How about here? Between 10 and 11. So I'm going to go here. I'm going to add printf quote unquote backslash n semicolon. Let me go back and recompile Mario. Dot slash Mario. And crossing fingers. Voila. Perfect. I printed out now 3 by 3. Now it's correct. It's not. If I was really nifty, maybe still not the best design. Where am I perhaps repeating myself? But yeah. Yeah, I mean, it's a huge deal, but now I have 2 people call these magic numbers. Magic is sensitive. Where did that come from? Just randomly put it in the middle of your code. And you also put the same thing here. Now I have to make sure I don't screw up and make one change and not the other. So it turns out to get back to these out. I can actually do something like this. Int n equals 3. And then I can change this to n and this to n, which is marginally better because now I only have to change n in one place if I want to make this thing bigger or smaller. It's still going to work the same. So make Mario, dot slash Mario, there's our 3 by 3. But if I want to make 5 by 5, let me change n to 5. Rerun make Mario, dot slash Mario, and now I'm bigger grid, 5 by 5. But this is a little fragile. It turns out there's another trick we should introduce. It turns out that C supports what are called constants, whereby you have a variable that you want to exist, it's useful, but you don't want to accidentally change it. Or if you're working with a partner in class or a colleague, or if you want your partner or colleague to accidentally change that value with their own code, you can go into your code and tell C, this is actually a constant integer, a const, so to speak, and this will just prevent you or someone else from doing something stupid by accidentally changing it elsewhere. The code is still going to work the same, dot slash Mario, but you won't be accidentally able to change it very easily to something else. And honestly, what we've now done too is set ourselves up to make this more dynamic. Let me go up here, let me add a CSV library so that we have access to get in, because now we can do something fancy like ask the get in function for the size of this brick wall, and then we can use n dynamically. So for instance, let me increase the size of my terminal, make Mario, dot slash Mario, size 3, gives me a 3 by 3, dot slash Mario, size 5, gives me a 5 by 5, dot slash Mario, how about 50, gives me a crazy big one, but it's all dynamic. And now I don't have to even change the code, it just now works. As an aside, if you wonder how I fixed overpass, sometimes it's just something up arrow. It turns out that Linux will remember, if you configure it all of your previous commands, so if you up, I can go through the past a couple hours of commands that I type, which is useful sometimes, a couple hours of commands to pass to you, just to save yourself some keystrokes. And another trick in the terminal window is to do this. If I do dot slash ma, and I get bored and I want to type out RIO, I can also just hit tab, and it will autocomplete based on the characters that you use. So those kinds of tricks do will save you time over time. But let's do this. It's kind of broken, arguably, if I do this. How about cat? Alright, well that works. That prevents me from doing something stupid, because get in only accepts integers, but it will accept 0, which does nothing. It will accept -1, which does nothing. And that's not bad. It's not doing something weird, but it would be nice to catch that and force the user to give us a positive integer instead, so we at least see something on the screen. So when we go back to my code and propose it, now that I have the CSS library, why don't we do something like this? I'm going to change this, I'm going to get rid of the constant, just in case the user needs to type it again. And what if I do this? While n is less than 1, so if it's 0, -1, -2, or whatever, let's go ahead and again ask the user for an int and ask them for the size again. And therefore, only once n is not less than 1 will this loop break out and we'll proceed to the rest of the code. So now let's try this. Make Mario, /Mario, 0. Didn't like that. -1, didn't like that. -2, didn't like that. 3, it did like that. So using a loop now, I can sort of ensure that the human is providing the input that I actually want. So this is correct, but I dare say 6 through 10 could be done better. Why is it poorly designed? Thank you. Yeah. Well, what repetition? Clear line? 6 and 9. Like, okay, so they're really the same. That's generally not a good thing. And maybe I can change this one to remind the user, like, hey, that's not a positive. So we might customize the method, but just have to complicate here for the most part is not a good thing. So it turns out that one feature C, one feature there's one other way that will actually help us eliminate this redundancy of using get in twice and particularly asking literally the same question, size, twice in duplicate. So I'm actually going to go into my code here, and I'm going to delete the loop as we've written thus far, and instead of using a while loop, I'm going to introduce instead something we typically call a do while loop, which is a little bit different. You begin with the keyword do, and then inside of the curly braces, what I'm going to do here is that same idea I want to do once and more times thereafter. So for instance, I'm going to say n equals get underscore in, quote unquote size, and then at the bottom of this block of code, then I'm going to use the keyword while, as well as parentheses and always for a Boolean expression. And here we're going to ask the question, do this while n is less than 1. But there's one fix I still need to do here, because notice on the current line 8, I actually haven't given n a type. I haven't declared n yet, but it would not be correct to declare n here, inside of that do block. But why might that be? Why would it not be good to declare n inside of these curly braces? Yeah, so we call this conditional scope. We call it the scope of a variable is generally confined to the most recent open curly brace in which that variable is declared. And so if I declare this variable on line 8, I'm not going to be able to use it on line 10. But there is a fix, even though it might get a little strange. I'm going to go above my do block here, and before I go into this loop, I'm actually going to declare n to be an integer, but semicolon, end of block. I'm not going to bother giving it a value because I know logically I'm going to end up giving it a value anyway, now on line 9. And so what's different about this version of the code is that the do while loop ensures that we prompt the user for input at least once, and then while that input is not what we expect, for instance, less than 1, then it's going to execute again, and see this message does that, do the following while this Boolean expression is true. So if I go ahead now and rerun, make Mario, compiles okay, /Mario, and now I'll go ahead and input something that's not correct, like 0, but I'm prompting again. Or something like -1, and I'm prompting again. But if I go ahead and input, for instance, 10, now, because that's a positive integer, I need to get a 10.